Setup for the EIE triaxial test. The test setup consists of the following components: a water container, vacuum pump, de-airing connection panel, de-aired water storage tank, triaxial cell assembly, triaxial testing machine, air-water constant pressure system, and an air pressure pump. Procedure: Triaxial compression test. Cast a soil specimen in split mold. First, cast the soil specimen carefully inside a split mold to the required dimensions. Next, place the rubber membrane inside the membrane stretcher. Fold the extra portions of the membrane at both the top and bottom over the stretcher edges. Apply suction through the suction tube to expand the membrane and stretch it firmly against the inner walls of the stretcher. Now, place a dry, porous stone and filter paper on the pedestal of the triaxial cell. Position the membrane stretcher on the pedestal and carefully insert the soil specimen into the membrane stretcher. Place another filter paper and dry, porous stone on top of the specimen, followed by the loading pad. Gently unfold the upper portion of the membrane to completely cover the top porous stone and loading pad. Carefully remove the membrane stretcher. Reinsert the membrane stretcher fitted with 2 O-rings. Position one O-ring at the bottom and the other at the top of the specimen to secure the membrane properly. While removing the stretcher, ensure the O-rings remain in place. Fold the membrane neatly over the O-rings to create a proper seal. Connect the water inlet lines to both the base and the top drainage outlets of the specimen. Place the chamber carefully over the prepared soil specimen in the triaxial cell. Tighten and seal the chamber uniformly to prevent any leakage. Finally, ensure that the loading piston is centrally aligned with the loading pad to guarantee uniform application of axial stress. The specimen is now ready for the triaxial compression test. Start the vacuum pump and open the vacuum pump valve. Open the vacuum supply valve and the water supply valve. Water will begin to fill the de-airing water storage tank. Once the water reaches the required level in the de-aired water storage tank, close the water supply valve and open the vacuum release valve. Air trapped in the water will be released in the form of bubbles, completing the de-airing process. Supply the de-aired water to the triaxial cell. When the cell is completely filled, water will leak from the top valve. Tighten the top valve to stop the leakage. Close the de-aired water supply valve and disconnect the water pipe from the triaxial cell. Place the triaxial cell on the triaxial testing machine. Connect the de-aired water pipe to the first cylinder of the air-water constant pressure system and open both valves to fill the cylinder. When water leaks from the second valve, close both valves. Repeat the same procedure to fill the second cylinder. Connect the cell pressure valve to water outlet 1. Connect water outlet 2 to the T-junction of the burette and connect the other port of the T-junction to the back pressure valve of the triaxial cell. Connect the compressor pipe to the air inlet valve of the constant air pressure system. Open water outlet 1 to apply cell pressure. Open water outlet 2 to apply back pressure through the burette. During the consolidated undrained CU test, gradually increase the cell pressure and back pressure until continuous saturation is achieved, with the B value reaching approximately 96%. Once the required B value is achieved, close the back pressure valve, water outlet 2 of the constant air pressure system. Simultaneously, open the burette valve and close the pour water pressure valve of the triaxial cell. Apply the required effective pressure, cell pressure, and record burette readings at standard time intervals as specified by ISO. Plot a time versus burette reading, milliliters graph, to determine the volume change. Proceed to the shear stage on the load frame and apply a uniform load through the LCD control screen. Continue loading until the sample fails. Once failure occurs, press the reverse button on the machine. Finally, construct the Morse circle. At EIE, we bridge the gap between testing and quality testing.